this is the video recording for Algebra 2, Unit 4, Lesson 1. All right, let's get into it. So for Unit 4, we're talking all about transforming functions, all right? And this overview will give you a quick little video, and you can watch that when you're going through. But basically, transforming functions is all about how do we undo, how can we move, how can we mathematically manipulate different functions. And we're going to learn all about that both using equations and looking at the different graphs that we can generate here. All right, so in lesson 4.1, we're going to learn how to deal with transforming functions through inverses. All right, so with inverses here, it's talking about undoing things. All right, and this should be relatively familiar. We've done this a lot with basic transforming equations and algebraically moving things from one side of the equation to the other, but now we're going to put some names to it and look at it mathematically. So again, inverses is just looking at things in the reverse mode here. Okay, so again, we're gonna talk all about inverses, what they look like, how they are, and again, here are our objectives for this overall unit here. Okay, so if we look at the 4.1.1 study on inverses, all right, this is talking about hackers and how they break into email accounts, okay, but basically what they do is they just undo the work that somebody else has done, right, and undoing the work is called, can be called inverses, right? So if you think of your email as a function, input is your password, output is access to the account, okay, so again, we're dealing with inputs and outputs. Input, again, is something like your independent variable. Your output is your dependent variable, right? It's dependent on something else. So basically what a hacker can do is they can undo security, all right? And a function or relation that undoes another function or relation is called the inverse, right? So if we have one normal function, something that undoes it is known as the inverse, all right? So if we look at this mapping diagram here, okay, we have n of x, and n of x is showing letters going to numbers. So a goes to 1, b goes to 2, so on. So if we look at the inverse function, it's the function that undoes n of x, right? And you can see here, if n of x takes us from a to 1, the inverse function takes us back from 1 to a, all right? And if we look here again, the function that undoes it is called the inverse. So this is the inverse of n of x, right? And basically what it does is it reverses the roles of inputs and outputs, okay? So the domain is the inverse, the domain of the inverse is the range of the original function, okay? So if you think about it, again, domain, x values, range, typically y values, right? So y now becomes x and x now becomes y, right? So input values, our our domain, and the input values here are actually our ranges. So again, it's something that undoes the other thing. Okay, so if we look here, you can see when we put it on top, right, the inverse of n of x undoes n of x. All right, so c goes to 3, 3 goes back to c with the inverse of n of x. All right. And you can think about the inputs and outputs as ordered pairs, right? So typically we think about them as x and y coordinates, but you can just think of them as ordered pairs in general, all right? So if our ordered pairs for our normal function, our forward direction function n of x, are a1, b2, so on and so forth, the inverse of that would be, again, flipping the domain and range, or flipping the x and y values. So now your coordinate pairs are 1a, 2b, 3c, right? So on. So again, you're flipping your input and output values in order to get the inverse. All right, so again, here's a couple more examples. 1, 4 is an ordered pair of a function f of x. The inverse of that is 4 of 1, and that's an ordered pair for the inverse function. All right, same thing, 27, 15, 15, 27. All right, you change the x and the y values in order to get the inverse. All right. So since there's coordinates for this inverse, we can also have an equation for this, right? So this one here is saying, okay, map out the function that's represented of x plus 2. So if this is our x value, right, this is our input, then this is our y value, our f of x, our output, right? So 1 plus 2 gives me 3, 2 plus 2 gives me 4, and 3 plus 2 gives me 5. All right, and sure, I'll submit it to make sure I'm right. Awesome. Okay. So now When we want to undo that, right? We want to undo that. We went from 1 to 3. Now we have to go back from 3 to 1. We went from 2 to 4. Now we got to go 4 to 2, right? And again, we're now trying to look at the function that undoes our add to function, all right? If our original was our add to function, now we need to undo the add to function. And I know it's really hard to see here, but this is f to the power of -1. Okay, so if our original function is f of x, we write our inverse function as f negative to the power of -1x, right? So that -1 is standing for our inverse. And f of x just being the general name for function, right? So we've got our original function f of x and our inverse function f to the power of -1 of x, right? And when we put them on top of each other, right, the mapping shows our add to function, right? So f of x, our original, is our add to function. So then the question becomes is what is f -1 of x, right? What's our inverse function? Okay, so the hint here is what operation undoes addition, right? When we're trying to move a value from one side of the equation to the other, if we're adding it in the original equation, we have to subtract it, right? When we're trying to move. So that is the inverse operation, or that's what undoes addition. All right. So the add to function, the inverse of that is our subtract to, right? And the steps for figuring this out mathematically would be we replace f of x with y, right? We swap our x and our y, we solve for y, and then we place our y with our f power to the power of -1 of x, right? So again, showing you this through this slider. Okay, we start with our original function, f of x equals x plus 2. We replace f of x with y, so we get x plus y equals x plus 2. All right, then we swap x and y, right? So again, we're flipping our domain and range values, right? So we flip. Now it's x equals y plus 2. Okay, but now we have to solve. Again, we're still solving for y. So what we did was we moved that 2 to the other side. So instead of plus 2, we are now subtracting 2. Okay. We use the commutative property. So by that, we mean we just flip. So instead of x minus 2 equals y, we now have y equals x minus 2. All right, and then the final step there is we replace our replace our y with our f to the power of -1 of x, right? Making it look back like a function and not like an equation, right? So now we replace our function with that f sub 1, and again, there's our summary of our steps here, okay? Moving forward. All right, so if we take another look at this mapping here, okay, what you can see again, oval goes down to 3, back up to 1. So again, if we were looking at our original function, 1 plus 2 gives me 3, okay? And then if I have 3 as my x value, 3 minus 2 gives me 1. Perfect, right? So as long as the functions undo themselves or you can get back to the original value here, then you know that you've done your inverses correctly. Okay? And how we can do this here is this thing called composition of functions, all right? And it's using the output of one function as the input of another, right? And we talked about this very briefly here. So when you had f of x and g of x, both of those were functions, all right? And then we composed f with g that gave us f g of x, and sometimes written as f of g of x, right? And again, what we can do is we can plug the values in, and again, get this composition of functions. So showing you how this works here, checking your inverses, okay, checking your inverses. So we looked at it using the mapping, right? And we figured out, okay, yes, it goes from 1 to 3 back to 1. Okay, how we can do that with equations without actually having to do that full mapping is we can do the following steps here. All right, so if we show the original equation and the inverse, so original f of x, inverse f to the -1 of x, all right? What we do is we replace x with f of x in the inverse, okay? So really what that looks like here is, so you can see we've got f -1, right? And instead of looking at it, evaluating for x, we evaluate it using our original equation here, okay? So what we're going to do is everywhere you see an x in this inverse equation, you're going to put x plus 2, right? You're going to fill that entire original function, okay? So there it is, boom. We have f of x minus 2, right? And f of x stands for x plus 2. So that's what we do next. We substitute that in, okay? And then we simplify, right? And we simplify. And as long as we get our answer equals to x, right, then we're golden, right? Because what this is saying then is basically if I evaluate this equation, I'm going to get back out what I started with. And that's, again, that's the ultimate goal here. If I put in an x value, if I do the normal function, I should get a y. And if I do the inverse function, when I put in y, I should get back out my x. All right. So here's a couple more examples that show you how to find the equation for the inverse. Okay, how to find the equation. So again, it is undoing those mathematical processes. So if we look at something that's maybe not as simple here, okay, we replace f of x with y. Okay, we do that in all three examples. We replace f of x with y, and then in order to get this 5 away from the x, we have to divide. Okay, so we divide. After we change our f of x into y, we flip our x and our y, right? And we end up solving again for y. So again, to get that 5 away, we have to divide by 5, right? Then we get our equation is equal to y equals x over 5. And then we replace our y with our function. But again, it's not f of x, it's f to the negative 1 of x. All right. Same thing with the inverse here. Okay. We have to flip f of x for y, right? Then we flip our x and our y values. And then we try to solve to get y by itself. So our first step here is move 3 to the other side by doing addition, right? Addition on both sides. Then we have to divide by 10. Okay, so we divide by 10, we get our new function, and then we change our y value out for, again, f to the negative 1 of x. All right, last one here. This one might get a little bit more difficult here, but same thing. You're just undoing processes that you already should know how to do, right? So for f of x is equal to 5x plus 1 over 9, right? We change it back to a y, right? We flip our y and our x. Now, what we got to do here is we got to get this 9 on the other side. So we multiply by 9, right? We multiply by 9. Then we end up with a 5y plus 1, right? And I just kind of skipped a step here, but we end up with 5y plus 1. So then we subtract 1 from the other side, okay? And then we're left with 9x minus 1 equals 5y. So then we divide both sides by 5, and we end up with our new inverse equation here. And again, you can always easily check by plugging in a value for x, calculating y, and then again, plugging it your value in for y and evaluating for x. All right, so a function or relation that undoes another function is also called an inverse. All right, inverse of the function is it works to undo that original function. So again, it flips the inputs and the outputs. It flips your x and your y value. And how we do that, again, those 4 simple steps right there. All right, we'll skip this and let you work on these so you can see some instantaneous feedback there. All right, but again, couple quick things here. So 3, 5 is an ordered pair, okay? So then you would flip those. It should be 5, 3. All right, and then you should work through these problems here before you do your quiz to make sure that you understand how to properly undo those functions. All right. Now, I'm going to hit this really quickly here because, as I told you at the beginning of class today, when you're undoing functions, right? We can do it easily with f of x, with x and y, because now we understand how to do that. But now when you're looking at other variables, you can treat them exactly the same way you do as x and y. So for example, here, you've got this function that converts Fahrenheit temperatures to Celsius, okay? So f and c. All right, you can act like f and c are x and y, right? Act like they're f and c are x and y. You just have to know which one you're trying to look for and solve for, and which one is your input and which one's your output here, right? So for example, if this is our equation, Celsius is equal to 5/9 times by Fahrenheit minus 32, okay? 32 is your input value, right? It's the one that you were able to put in, and the one that you're solving for is your output value, okay? So F here in this example is like your X value, and C is like your Y value, right? So when you're trying to undo the function, you treat them again just like x and y. So instead of f of c, which is function based on Celsius, right? You replace that for your y value or your c value, okay? Because we're solving for Celsius. All right. Then you flip, you solve, and you try to evaluate. Right? You flip, you solve, you try to evaluate. Right? So again, though, when we're solving for this guy now, okay, we mathematically are now solving for Fahrenheit, Okay, so that's the only real difference here. Okay, we can't actually say F and C are switching places, right? But we're now, instead of solving for C, we're trying to solve for F, right? So instead of solving for Celsius, we're trying to solve for Fahrenheit. So still, you want to undo the processes. So you got 5/9 there, you multiply by 9/5. That moves it to the other side. Then I've got Fahrenheit minus 32. Well, you add 32 to both sides, right? Now we've effectively undone our relationship so that we can go from Fahrenheit to Celsius or Celsius to Fahrenheit. Okay, so looking at another example of inverses here, okay, you can relate the sales made to the amount a person gets made, right? So the input variable is the sales and the output is the payment, okay? So if you're trying to figure out the inverse for this, okay, you would replace the function name with the output variable. So instead of P of S, we are now looking for P for payment, right? So payment is equal to 10 times S plus 300. Okay, so now instead of solving for P, we're going to try to solve for S. So we move that 300 to the other side by subtracting, divide both sides by 10, and then simplify if we can. So again, remember, if something's on the bottom here, you divide both of those numbers by that denominator. So P over 10, and then 300 divided by 10 is 30. So we can say P over 10 minus 30. All right. So the steps for finding an inverse of a function are always the same, no matter what the letters are used for the variables. Again, it's about knowing what you're solving for, knowing what your input, knowing what your output. How do you find the equation of a function's inverse? Again, you replace the function with the output variable, you solve for the input variables, and you replace the input variables with the name of the inverse function, right? Again, more practice that I will let you get at on your own time if you need more practice with it. Okay, bare minimum though, you need to, again, make sure you do these so that you are ready for your sample quiz here. But we'll talk more about your quizzes in a second. All right, so the function here, again, just undoing. So instead of having S of H, the first step you would need to do is replace this with the value S, right? Replace it with the value S. And then you would solve for H here, okay? And then you're going to replace it with the inverse function because now we're solving for H, so we have this function H of S, right? Which is why it goes from S of H to H of S. All right, same thing here. Instead of going from A of F, we're going to go from F of A, okay? So we need to solve now for F. So replace this with A, solve for F. All right, and again, we're going to move on here to part 2 of our review, which is our study guide. And again, I will post all the answers to all the study guides for you so you can have access to them at a later date. I'll do that once we get a little bit further along in this unit here. But for 4.1, the study sheet here, the study guide, whatever you want to call it, here are the answers below. So for inverses, an inverse of a function or relation that undoes or reverses, okay, so either of those answers would work. Basically, you're going to undo the work that another function does, right? So if we have the add 3 function, its inverse is subtract 3. All right, the function notation, f to the power of negative 1x. All right, so again, I know it's difficult to see there, but there is a negative 1 of x, so you've got to have that written. All right, so the domain of one function is the range of its inverse. Right, so again, you're flipping your x and your y values. Same thing, the range of the function is the domain of its inverse. Okay. So again, function, your input is x, your output is y. In the inverse, your input is y, your output is x. All right, so here are the 5 steps here to solving or finding the inverse of the function using using x and y. Okay, so again, you're going to replace replace f of x with y. So we replaced there, we swapped our x and our y values, right? Then we solve for y. So subtracting 3 from both sides, get y by itself. All right, then we want to put y on the left-hand side for formality reasons. So y is equal to x minus 3, and then we replace our y with our function, our inverse function notation, f to the negative 1. All right. So then moving forward here, you can use a composition to check that 2 functions are inverse of each other, right? So solving for an inverse of another. So if f of negative 1 of f of x equals x, then f of negative 1 is the inverse of f of x. So again, what that means is instead of putting in x where you see the inverse function, right? For the inverse function, you would plug in f of x, right? So you'd plug in that original function instead of just x by itself, and then you would solve. And if you end up getting x, that means they are inverses. All right, so using composition to determine if they are inverse functions. Okay, so what you're going to do is you'd show f of g of x, right? So f of g of x, which means that in this original equation, we have 3x minus 9. So instead of putting in x there, you're going to put in this entire function for g of x, right? So x plus 9 over 3. All right, then what you do is you solve. Okay? So then you have x plus 9 minus 9 equals x. Perfect, right? Perfect. Then you have to do the opposite. Okay, so you have to do g of f of x, right? You have to do it both ways because sometimes it might work out one way, but not necessarily both. So make sure you do both ways. You've got g of f of x, right? So again, in g of x, instead of having x here, you're going to put 3x minus 9, right? So you have 3x minus 9 plus 9. That gets rid of that. You've got 3x over x gives you x. All right. And again, the logic is they both equal x. Therefore, they are inverses of each other. All right. So then it says show the function that of f negative 1 of x equals 8x squared minus 2, where x is greater than or equal to 0 is the inverse function of this guy. All right, so you can ignore the x is greater than or equal to 0, right? That is a boundary condition, and what this is saying is that this function, or the inverse function, might not work if it is something less than 0, right? And we'll get more into that later on. But what you do is, again, you just plug in the inverse function into where you see x, right? So you plug in the inverse function. So where you see x plus 2 over 8 and then take the square root, you then plug in 8x squared minus 2 for the x value. When you solve, you get x. Same thing here. When you flip and you do the inverse and you evaluate that for f of x, you have here, you plug in the square root of x squared, or x plus 2 over 8 where you see x squared. Right, so that's what they do. Then you solve and you get x. So therefore, we get x for both cases. Therefore, they're inverses of each other. All right, and then finally here, fill in the blank to complete the rule. To find the inverse of any function, take the original equation and solve for the, input variable. Right, we solve for the input variable. All right, so what that looks like here is replacing the function name with the output variable. So the function right here is p of s. Right, so we're going to replace that with what we're actually solving for, which was p, right? Then we're going to solve for the input variable. So solve for s. Solve for the original input variable. We get s by itself. All right, again, same thing, formality, put the input variable on the left-hand side. Now, last step here to make it look all pretty, replace the input variable with the name of the inverse function. So the inverse function is going to be s of p for this one because now we are using p, so we're using p to solve for s, so that's what our function's going to be. We're using p to solve for s versus originally we were using s to solve for p. All right, and then finally this one here, you can go back and look at it, but this is going from Celsius to Fahrenheit, and we're flipping to going from, we originally are starting with Fahrenheit, right? Fahrenheit's our input variable, and we're going to Celsius. And then we're trying to calculate now how, if we have Celsius, what is our degrees in Fahrenheit? Again, this one was directly stated in the Apex, so go back and look at that. All right. And what we're going to do here is we'll go through a couple more problems in the checkup, and then I will post the same instructions on Google Classroom, but you are only going to do the 4.1.3 quiz. You do not have to do this quiz. This quiz is extra credit if you want it, but you only have to do this first quiz here. All right, so we'll go through the checkup and do some worked problems together here right now. Okay, so here are some of the worked problems we're going to go through for 4.1 on the checkup. Okay, so for this one, it's saying find f of negative 1 of x. Again, that's how you should see it written, which is the inverse function of f of x. All right, so again, when we're going through this, step 1 is to replace f of x with y. So you have y equals 9x cubed minus 4. All right, then you have to flip the x and the y values. All right, so you end up with x equals 9y cubed minus 4. All right, and then we start to undo the operations here. All right, so by that we mean plus 4 to both sides. So x plus 4 equals 9y cubed. All right, then I'm going to divide both sides by 9. So I end up with x plus 4 over 9 equals y cubed. All right, and then to undo a cubing, you have to take the cubed root of that. And what that looks like is, that looks like is there, right? So cube root, okay? And I'll move these guys up here so we have a little bit more room. But that's what that looks like, is the cubed root. All right, the cubed root. And yes, you do have the ability to do that on your calculator. That would be under your math functions, right? So if you look under math, you should be able to see that. All right. So then I'm left with the cubed root of x plus 4 over 9 equals y, right? Those undo each other, okay? So then, again, apologies. I made this a little bit larger than I wanted to, so let me shrink that down. All right. So now we move y to the other side. So y is equal to cubed root of x plus 4 over 9. And then the last step is we replace y with f to the negative 1 of x equals cubed root x plus 4 over 9. All right. So that's how we do that first one there. Okay. So same thing. Replace with y, 3 over x minus 2. Flip variables. X equals 3 over y minus 2. Then we start to undo the processes. So plus 2 to both sides. X plus 2 equals 3 over y. All right. Now here's one that might be a little bit different, right? To undo something on the bottom, you have to multiply both sides, right? So those end up canceling. So what that looks like here is y times by the quantity x plus 2 is equal to 3. All right, is equal to 3. And obviously we want to get y by itself, so we're going to divide both sides by the quantity of x plus 2. So I'm left with y equals 3 over x plus 2. All right, and then the last step there is to change that y into the f to the negative 1 of x, right? So writing it in that function notation for inverse. And there we go. There's our final answer. Okay, 3 over x plus 2. All right, and then the last one here on the top, y equals 2x plus 12. All right, flip our x and our y values, 2y plus 12. Subtract 12 from both sides equals 2y. And then we're going to divide both sides by 2. But again, remember, you got to divide the entire quantity. So if I show you what that looks like, it's divide by 2, divide by 2. So technically I have x over 2 minus 12 over 2 equals y. Right? And the reason I wrote it like that is because we can make 12 over 2 smaller. So this ends up being x over 2 minus 6, because 12 divided by 2 is 6 equals y. So then again, running out of space. So then we move y to the other side. Y equals x over 2 minus 6. Rewrite it as inverse function of x equals x over 2 minus 6. All right. And again, I'm showing a lot more steps than you have to here, okay? I'm showing sometimes how to undo the processes. But again, you don't have to show as many steps as I am. All right. So for this next one here, so 6, we said we were going to do number 6. Same process. Y equals 2/3 x plus 5. Switch. X equals 2/3 x plus, 2/3 y plus 5, subtract 5 from both sides, is equal to 2/3 y. All right. Now again, to get rid of 2/3, you're going to multiply by the opposite of 2/3. So that would be 3/2. The inverse. So that would be 3/2. So again, remember, it's the whole quantity. So you end up having 3x minus 5 divided by 2. 3x minus 5 divided by 2. All right, is equal to y. All right. And we could flip the y's. And what we can do is we can just write 3/2 x minus 5. Okay, so then last step, replace with function of x equals 3/2 x minus 5. There's our final answer. All right, and then one more problem here. Okay, so we have y equals 5x minus 1 over 2. Replace x and y. All right, so then we have to multiply by 2. So I've got 2x is equal to 5y minus 1. Add 1 to both sides. So then we've got 2x plus 1 equals 5y. And then we divide both sides by 5. So 2x plus 1 divided by 5 is equal to y. We flip y to the other side, 2x plus 1 over 5, and then write it in our inverse function notation, 2x plus 1 over 5. Okay, again, hopefully the math here is not too difficult. It's about getting a process down and making sure you're following through accurately every single time. All right, now the next two questions here, we're going to try to go through both of them. Again, I want to be cautious of time here since that was a concern. So, let's get at it. All right, so the function MD below relates the distance measured in miles that Bob can drive his rental car and the amount of money in dollars it will cost. Again, when we start talking about real world problems, we have to remember that sometimes our answers have to have these real units here. But since we're not actually solving anything, we're just writing the equation. That's not a concern here, but I did want to point that out. All right, so we have our equation right here. Okay, so this is our original equation. It's wanting us to write the equation which represents the inverse function d of m, which takes the number of miles driven as an input and returns the number of dollars owed. All right, so if our original equation is this m sub d is equal to 40 d minus 35. All right, so again, same thing. But now we, instead of using f of x and x and y's, right, we just have to do a little bit more logic here. So m sub d, right, so now we replace that since we are trying to solve for miles, right, so we write m is equal to 40 d minus 35. All right, same process here, except for now instead of physically flipping, we're just going to solve. Okay, so we're going to solve for d instead. All right, so we have m is equal to 40d minus 30. So now let's solve for d, which stands for the number of dollars owed. All right, so we're going to divide both sides by 40. So I'm left with m over 40 equals d minus 35. Right, then I'm going to add 35 to both sides to get d by itself. Right, and then I know it's just a formality, but we still need to make sure we put d on the other side. D is equal to m over 40 plus 35. Right, and then we are going to change now into the function. If you forgot what the inverse function was called, it was d of m. So capital D of m, which means we are using m to solve for d, m over 40 plus 35. All right, so that's that first one there. Okay, scrolling back up here for number 10. For number 10, the function AH, which is given right there, relates the area of a triangle with its given base. All right. So we're trying to then write the equation that represents the inverse function capital H of A. Right, so we have A of H is equal to 7H over 2, and we're trying to solve for the inverse function H of A. Right, so first thing is we got to replace A of H with lowercase a, 7H over 2. All right, so now we need to solve to get h by itself so we can have that inverse function. So, going to multiply both sides by 2. So, 2a equals 7h. Divide both sides by 7 there. So, 2, 7, a equals h. Right, then we're going to flip so that we have h on the left side, so h is equal to 2/7 a, and then we write it as our function. So capital H of a is equal to 2/7 over a. All right. So again, you can still work through those problems. I definitely suggest you go through those multiple choice. And then there's still obviously a couple left here. I left you 4, 5, and 7. All right. So please reach out if you've got any questions. And again, you're only taking that first quiz, not both of them.